So very good morning my dear students. Today we will discuss velocity analysis of mechanism. So before going to discuss the velocity analysis of mechanism, we should know, or we should discuss the velocity analysis of link, because ultimately if we join link one by one, and if you fix a particular link, we will find the mechanism. So it is very important to study the mechanism of particular links. Okay. So velocity analysis. So first of all, we'll discuss velocity analysis of a link under pure rotation. Velocity of link under pure rotation. Velocity analysis of link under pure rotation. So suppose if you consider this is a link, okay, so it is fixed at O. So link is under pure rotation, so this angular velocity, this omega, suppose link A. Okay, so we'll find out the velocity of the link at different points. Suppose at point A, so what will be the velocity? So velocity VA, that will be omega into length OA. Okay, now this velocity is the absolute velocity. Okay, why it is called absolute velocity? So when we find out the velocity of a particular link with respect to some fixed point, that velocity is called the absolute velocity. Okay, so that is the absolute velocity VA. Now what will be the direction of this link? What will be the direction of this link? That will be the VA, that will be the perpendicular to the link OA. Okay, so that is perpendicular to link OA. Now if you consider another point, suppose B. Okay, so we will find out the velocity at B. So it is also direction VB. So VB, so VB will be omega into OB, because we are finding the velocity of B with respect to this point O. That's why VB is equal to that omega into OB. Okay, so that is also perpendicular to OB. Now we can see that at different point of the link, that velocity is different. Okay, when the link is under pure rotation. Okay, now we'll find out the velocity of link. Suppose that link velocity of different points, that means relative velocity. Suppose that is A, that is B. Now that is fixed, so relative velocity. Okay, now relative velocity, first of all we find out the velocity of A, velocity at point of A on that particular link, so VA. So we are finding out the relative velocity, so velocity will be VBA. Okay, so we are finding out the relative velocity of A with respect to point B. So velocity of A with respect to point B, VBA. So it is with some angular velocity omega. So what will be the relative velocity of A with respect to B? That will omega into AB. Okay. Now relative velocity of B with respect to A, V AB. So that is also omega into AB. Okay. Now relative velocity of A with respect to this point, that's why VBA, that omega into AB. Again relative velocity of B with respect to this point B. Okay, so that is also omega into AB. Now direction you can see, suppose a relative velocity, so that is perpendicular to this AB. Now relative velocity of B with respect to this point B, that will be in opposite direction. Okay, so that is also perpendicular. Okay, so when you are finding out the relative velocity of A with respect to B, so we have taken B as a center of rotation, and when we are finding out the relative velocity of B with respect to A, we are taking A as a center of rotation. Okay, now we are going to find out the velocity analysis. Velocity analysis of moving link. Okay, under sliding motion. Velocity analysis of a moving link under sliding motion. Okay, now suppose this is a link. Okay, so under sliding motion, suppose that is fixed and that is a moving link. Now consider a point, suppose A. So velocity of VA. Okay, another point you can consider this B. Okay, velocity is VV. Now you can see, as this link is moving with some fixed support, with the fixed sliding, so that is sliding, so moving, the link is sliding with the plate. So in that case, velocity of point A, VA, and velocity of point B are equal. So we can write that VA is equal to VV, that is equal to 0. Okay, so relative velocity of A and B, that will be 0 in that case. Okay, now in case of mechanism, okay, if you consider any mechanism, so mechanism is not pure rotation or not pure translation. Okay, here we can see that we have considered the velocity analysis of a link under pure rotation. Now velocity of this link is in the translation. Okay, sliding in particular direction, that is translation. Now when you consider any mechanism, so mechanism, or if you consider any moving body or any body, that body is not under pure rotation or not pure translation. whenever any, if you see any particular link or in a particular mechanism, that particular link is not pure rotation or pure translation. Okay, so any type of motion, so that can be divided into rotation and translation. Any link, suppose this link, if you consider that link, it is rotating. Normally you can see it is rotating. Suppose if you consider that this suppose earth. So if you consider this earth with respect to this earth, if you see a particular link, so that link is, normally you can see this is moving, but actually this link is also rotating with respect to this earth center. Okay, as the size of the earth is much more compared to this particular link, so we cannot see that particular rotation of this link. So any motion of a particular link in a particular mechanism, so we can consider it is a rotation plus translation. Okay, so any type of motion can be divided into translation and rotation. So there are two approach to calculate the velocity of the particular link in a particular mechanism. So one approach it is called instantaneous center of rotation. Instantaneous another is relative motion method. So instantaneous center method and relative motion method. So among this, by using this two method, we can find out the velocity of a particular link in a mechanism. So among these two method, instantaneous method is very simple, and by using this method we can find out the relative velocity or velocity of any link. Okay, but this relative motion method, it is some confused method. Okay, so you can use particular instantaneous method to solve any type of problems regarding the velocity. Okay, so first of all we will discuss the instantaneous center of rotation method. Now first of all we should know what is instantaneous center of rotation. Okay, now suppose a body suppose this pen. If you consider that body is a particular instantaneous, that means particular instant, at any instant of time. So any instant is a combined rotation and translation. The body is under rotation and translation. Okay, the motion is under rotation and translation. So it is assumed to be the motion of pure rotation. Suppose if a link is moving with rotation and translation, so in that case we have to assume that the link is under pure rotation about some imaginary center of rotation. Okay, once again I am telling, suppose the link is moving under pure rotation and translation. Motion is rotation and translation. So we have to combine pure rotation and translation as a pure rotation about some imaginary center of rotation. That imaginary center or imaginary point is called instantaneous center. Okay, Now we'll give some example. So instantaneous center is change with the change of the position of the link. Okay, suppose, so in order to find out the velocity by instantaneous center method, I will give some example. I will show you some example. Suppose a point A, in a particular, suppose link, that is the link, that is a point A. Suppose direction of this velocity, suppose VA. Okay, again we consider a point B. Okay, so suppose direction of this link is, suppose that is VB. Okay, so in a link, a point A and point B. Okay, so we have to find out, suppose that is instantaneous center, suppose that is instantaneous center I. Okay, so how to find out the velocity? Suppose we do not know the direction of this velocity V. We do not know the direction of velocity A, B, and VB. We do not know the direction of the velocity A and B. So to consider a point which is instantaneous center, so we joined A to instantaneous center I, and from point B we joined another point from B to I, that is instantaneous center. So join these 2 points which will be perpendicular. Okay, so earlier, suppose it is not known velocity B and BB known. So if you find out the velocity of VA and velocity of BB, we have to find out the instantaneous center of rotation, so that we can find out the velocity VA and BB. So that is the procedure. Suppose at a particular instant, that is the instantaneous center, so join A to I and join B to I. Okay, and we know the direction of VA and direction of VB, that will be perpendicular to the line, AI and IV. So that is perpendicular. So that is the velocity of VA and velocity of VB. Okay, now again, suppose VA and VB, that are not equal. Okay, velocity of VA and VB are not equal. So in that case, how to find out the instantaneous center? Okay, how to find out the instantaneous center? Suppose again we consider a link. If you consider a link, suppose a point, and that is another point. So one is A and another is B. Okay, so V and BB are not equal. Okay, V and BB are not equal. So suppose direction of VA, okay, suppose direction of VB. Now we have to find out the instantaneous center. We have to find out the instantaneous center. So what is the procedure? So that is VA and VB. So you draw a line which is perpendicular to VB. Okay, so another line, so that is perpendicular to VA. So the line, two lines where it is intersecting, that is the instantaneous center. Okay, so two lines are intersecting, that particular point is called instantaneous center. Okay, suppose VA and VB which are parallel, VA and VB, VA and VB are parallel to each other. Okay, so in that case both are parallel but are not same. So in that case, suppose this is a link, suppose that is point A, that's point B. Now VA and VB are parallel but not same, velocity are not same, suppose VA and that is VB. Okay, now how to find out the instantaneous center? So in that case you join A to B, okay, and you extend, and from VA and VB you join this 2 point and you extend it, so it will intersect the line AB. So that is the instantaneous center. Okay, so that is the instantaneous center. Now BA is equal to, suppose it will have some angular velocity omega into IA, and VB is equal to omega into IB. Okay, so VA by VB is equal to omega into IA by omega into IB. So IA by IB, VA by VB. Okay, so that is one case. So another case you can consider, suppose VA and VB are parallel but opposite direction. Okay, so VA and VB are parallel but VA and VB are parallel to each other. Okay, parallel to each other but opposite direction, direction is opposite. So suppose that is a link, that is a point, that is another point. So that is suppose A, that is B. So direction, suppose VA, so another direction VB. Okay, now we will find out the instantaneous center. So how to find out instantaneous center? So join A to B, and from VA to VB you join, so it will intersect a particular point, so that is the instantaneous center. Okay, some other example we can take, suppose in a plane, a circle which is rest in a plane. So where will be the instantaneous center? So instantaneous center will be at a joining point. Another case you can consider, suppose that is a link, this is turning pair. So what will be instantaneous center? It will be the instantaneous center. Okay. Another case you can consider, suppose body which will be under sliding motion. Okay, so it is some angular velocity, some velocity will be there. So we need to find out the instantaneous center. So in that case, what will be the instantaneous center? So instantaneous center will be at infinity. I will be at infinity. Okay, now we will solve one problem using the instantaneous center method. Okay, suppose a rod, it is a rod, okay, which is resting in a wall, at 2 points. One point is at B, another point is at A. So that is a wall. That wall is with 60 degree with the horizontal axis, and the rod is at 20 degree with the plane. Okay, now velocity at point B, velocity is known, that is 2.4 meter per second. Velocity at point B, that is 2.4 meter per second. Okay, so you have to find out the velocity at VA, velocity at point A we have to find out. Okay, so question is, a rod is sliding, a rod is placed in a wall. This wall is at a 60 degree angle with the horizontal axis, and the rod is at point B, which is 20 degree with the horizontal plane. So VV is given, we have to find out VA. Now you can see direction of VV. In that case, we have to find out the velocity at B. To find out the velocity at point A, we should know the direction of this velocity A and the direction of velocity B, and also we should know the instantaneous center, because we have to find out by using instantaneous center method. Now you see that what will be the direction of the velocity? Direction of the velocity B, that is VV direction. And what will be the direction of A? What will be the direction of A? Direction of A will be this VA. Okay, now how to find out the instantaneous center? So from VB we have to draw a line which will be perpendicular to VV, and you can see another line is here. So we have to draw another line which will be perpendicular to VA. So that is 90 degree, that is also 90 degree. So that is the instantaneous center of rotation I. Okay, now we have to find out this three angle here. Okay, so what will be the angle? So it is 20 degrees, so that will be 70 degree. Okay, so this is 60 degree, so that is 30 degree. Okay, so that is also 30 degree. So that is 30 degree, that means 60 degree. So 60 plus 70, 130. So that is 50 degree. Now we can apply sine law. So what is the formula? VA by VB, that is equal to IA by IB. So IA by, if you use sine law, so IA by sine 70 degree. Okay, so sine 70 degree, and IB by sine 60 degree. So we know VB, we know the VB, so VA, that is equal to VB into sine 70 degree by sine 60 degree. So that is known, VB is equal to known 2.4 into sine 70 degree by sine 60 degree. So that is the velocity of point A using instantaneous center of rotation. Okay, so we can use another problem we can solve. So that is problem number 1. Problem number 2. Now question is, a rod which is at 20 degree, okay, with A, okay, and direction of this point is 45 degree. So length of the link is 2 meter. So which is oriented 20 degree with the horizontal plane, and the magnitude and direction of the velocity VB it is given, direction is given, point B direction is given, and velocity VB, that is 1 meter per second. Okay, so direction of velocity VB, direction is given, that is 45 degree, and magnitude is given 1 meter per second, and direction of VA, that is also given, VA, that is also given. Okay, so you have to find out the magnitude of VA, magnitude of VA we have to find out. Okay, so as direction is given, direction of VB is given, and direction of A is also given, but magnitude of point B it is given, VB is given, VA is not given. We have to find out VA. So in that case, as direction is given from point A, so it will be perpendicular. Okay, so draw a perpendicular line, and it is also given, so draw another line which will be perpendicular to VB. Okay, so we have got instantaneous center of rotation I. Okay, now as it is 45 degree, so that angle will be also 45 degree, so that is also 45 degree. Okay, so that is 20 degree. Okay, so that will be 65 degree. Okay, so that is 60 degree, that is 20, that is 70 degree. So that will be how much? That also 65 degree. So what will be the formula? Formula is VA by VB is equal to IA by IB. So IF, again you use sine law. So IA by that is IA by, that will be sine 65 degree and IB by sine 70 degree. Okay, so here that is 45, so that will also 45, so that will be also 45 plus 45 plus 20, so that is 65. Okay, so using this VA is known, that is VB is known 1 meter per second, so VA is equal to 1 into sine 65 by sine 70 degree. So that is the velocity of point A. Okay, so by using this instantaneous center, by using the instantaneous center of rotation, we can find out the velocity of link A and B. Okay, so that is the instantaneous center of rotation method. So next we will discuss the instantaneous center method to find out the velocity of mechanism. Here we have find out the velocity of a particular link. Okay, next we will find out the velocity of a particular mechanism. Okay, so hope you have understood. Thank you.